Okay, so this is the prep video for section 3.1, which is continuous compounding. This is a topic that may look familiar to you because you may have seen it in pre-calculus, but we'll just go over it briefly for preparation for our class. So the first thing we want to look at is what the formula is for continuous compounding. And so it is this: A equals P e to the RT. So let's identify all the pieces. P stands for principal. That is your initial amount. So we have P is principal, or initial amount. A is the future value. You might rightfully guess that T is time. Importantly, the units of this time must match the units for the interest rate. So if your interest rate is given per year, then your time must be in years also, and always you have to compute with decimals, not percentages. So let's just do a few examples. The first one is this one. Find the value at 14 years of $1,000 initially invested at 5% yearly. So we're assuming that all of these are continuous compounding. So we're going to look at this equation and plug in the pieces we know. And I'm a big fan of writing out the equation so that then you can sort of drop in each piece and make sure that everything fits the way you think. So 14, that's going to be time. $1,000 investment, that's our initial investment, so that's P. And 5% will be our rate, but we need to convert that to decimal. So that means we know everything except A, so we'll just plug in 1,000 times e to the 0.05 times 14. I've got my calculator. And the reason I wanted to compute this actually sort of in front of you is just to note some things as we're going along about how to use your calculator with regard to E and ln. So E is actually, we didn't talk about that, E is a value that's approximately 2.7. E is a number, much like pi. Pi, we all know, 3.14. E is about 2.7. And it's just it's a value that occurs naturally. There are very many natural processes that, that use this, this constant E. So it is on your calculator as well. And so here we'll just say 1,000 times E minus the second function over the ln, 0.05 times 14. Mine shows the 0.05 and the 14, it looks like it's actually in an exponent. That means it's correct. If yours starts with a parenthesis, you have to remember that if you were going to do anything after this, you need to finish the parenthesis on your E, on your exponential. So I get 2013.75. I think it makes sense to round it there because this is a dollar amount. So remember, you do need to include units on any word problems. Okay, let's hop over to these other two. This is the easy one because this is just a straight computation. These over here are going to require doing a little bit of solving of the equation before we can do the final computation. So here, what do we know? We're going to start with the same. A equals P e to the RT. Find the rate, so we're looking for R. We don't have that. Do we have everything else? For $1,000, that's our initial investment, P, to grow to $2,000, that's our future value, in 10 years, that's time. So let's plug in everything. 2,000 equals 1,000 e to the R times 10. So now we need to talk about how to solve this equation. You need to get into R, but before we can do that, we sort of have to, I think of solving equations like peeling back layers. We can't get to the exponential until we move the 1,000 that's in front. So we'll divide both sides by 1,000 first, and we'll get 2 equals E. And I'm just going to rewrite that 10R, R times 10, 10 times R, same thing. So now the next thing I want to undo, I can't get into this R until I undo an exponential. How do we undo exponentials? With a ln. So we're going to take the ln of both sides. That undoes it on this side, so we'll just get 10R, and then ln 2 there. And then finally, we're going to divide by 10. Okay, so this is one where, again, you need to be careful with your parentheses. When I type ln 2, it opens a parenthesis. If I were to say divide by 10 directly after that, it would be taking the ln of 2/10. That's not what I want. So I need to finish the parenthesis and then divide by 10. And I got 0.069, or about 7%. Okay. Okay, sorry I ran out of space. Okay, so then the last one. So this is one where, again, plug in all the pieces you know and then solve for what's missing. This is going to be one similar. Find the time for 1,000 to double at 3% yearly growth. So let's look at what we have. I'm looking for time. I have my rate. I have my initial investment. I don't actually have my future value. Well, they said, but I do have information. I want my $1,000 to double. So I really know that my future value is $2,000. And we'll talk about doubling problems because, in point of fact, you don't even really need to know your initial investment in order to figure out how long it takes to double. So we'll talk about that. So again, we have the same thing is up here. We're trying to solve for something that's in the exponent. So the first thing we're going to do is divide by 1,000. So here's where I say it doesn't really matter what you start with. If I started with 10,000 and I doubled to 20,000, the first thing I'll do is divide. I'm always going to get a 2 when I double, when I'm looking at a double situation. I would go ahead and set it up this way, but just know that if for some reason you don't have that information, you can either think of something or just know that you'll end up with this 2 on this side. So again, we'll take ln of both sides and then divide both sides by 0.03. I know some people really like for the variable to be on the left-hand side. It really doesn't matter. If you prefer for the variable to be on the left-hand side, go ahead and at some point along the lines just reverse the equation. So again, here we're going to say ln 2, again we have to finish that parenthesis, divided by 0.03, and I get 23.1 years. Okay. So this is how we use this continuous compounding formula. One thing I wanted to point out that's kind of interesting here is that there is something called the rule of 72. And if you notice, all of these were talking about doubling, right? This 1,000 turned into about 2,000. That 1,000 turned into 2,000. This 1,000 into 2,000. If you want to know the time to double, a rough rule of thumb, rule of 72, is to take the amount of time times the let me say that again. To double, basically what it means. Doubling your investment occurs when the rate times time equals 72. That's kind of weird. So let's think about this. If I were at 5% yearly, 5% times 14, 5 times 14 is 70. That's about doubling. Here, I had 10 years at 7%. That resulted in doubling. 10 times 7 is 70, about 72. Here, I have 3 years times 23, 69. Again, that's about doubling, about 72. So that's it. I hope that is enough information for you to get started on the problems, and I'll see you in class.